go ahead and get started. So we're going to be taking a really basic look at Unreal Engine, show you how to navigate Unreal Engine, how to create a project, how to download assets from the marketplace, which has lots of free content that you can use in your projects. And then we'll show you the very basics of blueprints, which are essentially classes like in Java or C or whatever programming language you prefer, except rather than typing the code, it's one of those visual scripting languages, and so you're going to be dragging and dropping little boxes that represent code around on the screen to make stuff happen in your game. So I'm going to pass it off to Lucian to show you how to create a project.
Yeah, so when we want to initially get started with our project, the first thing you want to open, and hopefully people have the version of Unreal Engine that we're going to be working on installed. If it's like the early access version of 5.0 or any Unreal Engine 5, it should be okay. I believe the few things that did change in 5.1 are mostly related to input, and we're not going to be going over that today. So any Unreal Engine 5 works. I mean, even Unreal Engine 4 might work. You just might get some different UI elements and some things in different places that might not make sense. So I'm going to go ahead and launch Unreal Engine 5 here. And it might take a second, it might not. Let's see.
Also, if at any point you guys have questions, feel free to type it in the voice channel chat. I'll try to keep an eye out, or just unmute and say it. There will be some echo, but if it's a long question, I'll mute while you're talking. So.
Yeah. Okay, and we're going to be using the first-person example project here, because one of the things we're going to do later on is try and get a barrel to explode one shot. So let's do this. We need to make sure that we're in blueprint mode right here. C++ just means that you can write like actual C++ code and compile it using an editor like Visual Studio, but that's a little bit involved. So for now, we're just doing blueprint desktop, and we're going to do... This doesn't really matter right now. I always prefer to switch it to scalable, though, just to make sure that if you're making an actual game, you can adjust the graphics settings for different machines later on. In maximum, it kind of puts everything to the highest quality level. It might enable ray tracing and such, and that's not going to scale well to all systems. So we'll also make sure that starter content is enabled and give it a name. So in this instance, I'll just call it my first project. Anything works. And it'll create a folder with the project name in whatever directory you choose. So in this instance, I'm in the Unreal Projects folder. It'll create a folder inside of it called My First Project. And let's go ahead and create it.
And, if you need us to wait at any time because your computer is slower, let us know. Because I know before I just got a brand new laptop, but before it took me a good couple minutes to create a new project. So we can definitely wait if you guys are following along and want us to. Mm-hmm. All right, well, then I'm going to move right along. Just to show off what the starter content comes with right off the bat, if you hit this green play button, that's going to play the game as it is before we've changed anything. And so you can see, without us doing anything, it's come with a first-person controller. We can walk around with WASD, space to jump, shift to run, control to crouch does not work, but we can pick up a gun, and we can shoot it. It makes a horrible noise. So sorry about that. We even have some physics going on here. So you can see the template comes with a lot of stuff without you even having to do anything, which is pretty cool. To move around when you are not in play mode, if you want to just fly around the level, you're going to hold down right-click on the level, and you'll be able to look around just by holding down right-click and drag, and then you can use WASD like you would expect to be able to move around. And then down here is the content browser. This might be hidden by default, but you can click on the content drawer right here and it'll pop up if you don't have that. So this is where you're going to have all of your content. So everything from levels to your blueprints, which are like our code, to your materials for your objects. Everything that you're storing is going to be in here. On the right, this is called the outliner. And this is a list of everything that is in your actual level. So for example, if I select a cube over here, you can see which cube that is right here. It's named Chamfer Cube 10. And so this is this literally has everything in the entire level. You can select the sun, like all the light sources. This is the skylight right here. You can select where you spawn. So this right here is the spawn point. You can see if I were to move this over here and push it up on top of this box and then press play, it should spawn us, on top of this box when we press play. So definitely going to be using a good mix of working with your content that you've imported down here and then with your level up in the top right. The details pane, kind of self-explanatory. Whatever you have selected, it's going to list all the details for it. So if I click a cube over here, move over to it, and I start changing rotation values, it's going to rotate our cube. Pretty basic stuff. If you've used any sort of 3D modeling software or anything like that before, this will all be very natural and intuitive. But as you scroll down, you'll get to more complicated stuff, such as physics. So you can disable gravity. You could choose whether or not someone's going to be able to step up onto an object. All sorts of different settings, which you can get into more later, but we're sticking to the beginning stuff right now. So let's go ahead and make a cube. So you can see if I were to go ahead and copy and paste one of these cubes, it adds a new one on the sidebar. But if I make changes to this cube, such as making this cube larger or smaller, it's only changing the one individual cube. It's not changing all of the cubes. And so what if we want all of our cubes to be uniform and behave as one class, essentially? So that's where we would make a blueprint. So let's create a new blueprint for our cube. We can go into any of these folders. Maybe I'll just make it right in the root directory so it's obvious. So we're going to make a new blueprint class. I'm just right-clicking in the content drawer in whatever folder you want. And then you're going new blueprint class. And you're going to get a list of different classes that you can inherit from, essentially, if you've started inheritance at all. So you can read the brief description about what each one is. Since we are just making a basic object that's going to be in the level, we're going to choose actor. So you can see it says an actor is an object that can be placed or spawned in the world. If we were doing something that we wanted to be able to be controlled, we would use a pawn or a character, which is a type of pawn that includes the ability to walk around. There's lots of different things that you can pick from to inherit from. Actor is the most basic one. That's what we're going to do because we're making something very basic. I'm going to call this my cube. So we've created our class or our blueprint, and we can double click to open that up. And now you're in a whole other window here, which has a few different sub-windows. So the viewport is where you're going to make your physical object, and then the event graph is where you're going to put your code, except, like I said, it's visual, it's not code. Remember to stop me if you have any questions. So, going to the viewport, we know we're making a cube, so let's add a component in the top left here. And we can add all sorts of things. You could make it play audio, you could make it a plane, a sphere, whatever. We're adding a cube. And it's going to start us off with this default cube. You move around the same way in here. Hold down right-click, WASD. And so now we've created a blueprint for our cube. It's that simple. So if I were to put the cube into the level, we now have our little MyCube blueprint. And let's say I want to put a few of these in here. I'm just going to drag and drop a couple different MyCubes. So before we would have had to resize these all one by one. But now if I wanted to resize all of the cubes, I could go into the MyCube class or the blueprint here. And I can take the scale. Now let's make it wider. So I'm just going to change the X scale. Now we got a rectangular prism. My cube is not an accurate name, but whatever. And if we compile it and save it and go back to our level, look at that. All those cubes we placed in the level are now not cubes. And so that's something that you're going to get used to a lot. Everything that you're duplicating a lot, you're going to make a blueprint. So when we pick up the gun over here and we shoot these balls, that was a blueprint that we spawned. That sphere right there was probably a bullet blueprint or sphere blueprint. Oh yeah, and I should probably use proper terminology. So each of the cubes that I'm dragging into the level, that's an instance of the class, pretty much.
So now what we're going to do is we've seen how to create a blueprint, how they're all instances of this main blueprint right here, and how editing this one affects all of them, but we want to add some interaction to this now. We want to make it a little bit more interesting. So what I'm going to go ahead and do here is change all of these cubes into barrels that you can shoot, and then they'll explode. But we don't really, on its own, we don't have any type of like mesh that we can use to represent a barrel. We could just put a cylinder in here, but I want to make it a little bit prettier. So what we're going to do is go into the... So I just opened the Epic Games launcher, the same thing that you use to go to actually launch the engine. And I'm just going to go up here to, you see where the library is? Go to the Marketplace tab instead.
I have a question.
Sure, yeah.
I was wondering, how do you know the difference between what's called, like an instance copy or a linked copy?
Of blueprint actors?
No, like if you have a couple instances that all share the same reference, or are all those three different clones?
So these all, everything that you create in your world, like all three of these are just instances. They're copies of this base MyCube class. They're not linked. They all store references to that base class. So if you, for instance, change one of these in the world, it's not going to change the others. These two aren't linked to each other in any way. They're just linked back to this base class right here.
Okay, so if you change one of them in the editor, they won't change all of them. Only if you change the original reference.
Yeah, if you touch these at all in the editor, it's not going to do anything to the others. You have to go into the actual blueprint right here and change all the properties in here, and then they'll propagate to everything else.
Okay.
So, yeah, that's a good point to demonstrate then. What happens if we make one of them really wide?
Yeah.
And now go edit the default one again? Is it going to sync it back up, or is it going to...
Once you've edited... Yeah. So it does something a little weird with the scale. It actually... so you see I have... It's going to be kind of weird to show here, but if I scale this one up, you can see it scales the other one up, but it applies the transform that I've already applied to it beforehand. So in here, let's see, I have a scale on the y-axis, which is what I'm doing here. I'm scaling it by the y-axis, and I have that at a scale of 2. So what that's going to do is if our base class right here is also at a scale of 2 on the y-axis, this is going to become 4. So they apply on top of each other. Whatever, if it's something, if it's a number here, like the scale, and it's being multiplied, it's going to be multiplied by whatever you get in the base class. That doesn't mean that's going to happen for every property, because there's stuff like meshes and materials that don't just multiply. And in that instance, if you apply things down here, they'll just override whatever you have in your base class. But yeah, there's some interesting behaviors like with scaling that it'll actually just multiply the existing class's variables.
Oh, and before you move on, I do want to add, you were wondering how to tell if something is an instance of a class. If you go on the right in that outliner we talked about, you see how all three of the things labeled MyCube, MyCube, MyCube2, MyCube3. On the right, it just says Edit MyCube, because they're all from the same base class. And so if you click on any of those Edit MyCube buttons over there, it's going to be editing the same parent, essentially.
Understood. And how would you make a separate instance of that class?
So every time you want to make a new instance of this class, you can just drag it out into the world, and that has just created a new copy of it.
All right. Sorry. How do you make a separate duplicate of a class?
Oh, a duplicate of it. So okay, in the content browser here, this stores all of your blueprint classes. If you want to create an identical copy to this that you can edit and have have it be its own object, you can just duplicate the actual item in the content browser. Let's say we want to make this MyCube2, and we want to make this one...
Make it red, maybe, yeah?
Yeah. Let's go into the... I guess this is a good time to show materials, too, so I can show them at the same time. So let's go and we can create a new material. What I did there is instead of going into the blueprint class option, I right-clicked and I just chose the material option. And that's just going to throw new material in whatever folder you're currently in. And so I'm just going to name this red. It doesn't need to be that amazing. So this is going into a few, new topics, and I'll try and wrap back around to your question. But this is the blueprint, the kind of visual scripting language we were talking about. This is a little bit different because we're editing a material, but it has the same kind of concepts here. So if I go anywhere in the graph and right-click, we can create new nodes. And there's a bunch of different categories of nodes, and it's kind of context sensitive, so it changes based on what you're editing. In this instance, like I said, it's a material, so it's going to show me a lot of material-related nodes. In this instance, I just want a color, or a vector, I guess. I believe I can type. Oh, God. What I just did right there, that was not very clear at all. But if you hold down the V key on your keyboard and click anywhere on the graph, it creates a new parameter, a vector parameter, and this can be used to represent our color. So I'm going to name this base color and attach this white node, which is the whole color, not just one of the RGBA components. This is the whole color, and we plug that into base color. And now if I go down to this vector parameter thing right here, we can adjust the default value of that color. So let's make this red by bringing that up and click OK. Maybe I can, yeah, that's weird that it didn't apply in that editor, but I can just adjust the R component there.
Oh, and I just want to throw in, since I didn't cover this in the basic UI, on the left you can see the preview of your material applied to just a basic sphere. And so you can see later on, if we were to make it a more complex material, add some bumps or make it shiny if you're making a metal thing. I know it comes with a little bit of shine by default. You'll be able to see all of that in that left pane there.
Yeah. Okay, so we have, and the other interesting thing about these properties right here, I don't think we're going to go over it this time, but you can create instances of these materials and change just the properties that you've exposed. So if you want to have like a base, like a emissive color or something, or you want to apply a texture, but you want to be able to adjust that texture's color, you can create instances of that base material, although that's a little bit more involved. So for now, we just have this red material. I just did Control S to save it, and there we go. And I can just, up here in the tab, this has all of the actors and materials and such that we have open, so I'm just going to close that now.
Before we completely go off, I was just wondering, is it close to like the Blender node tree?
It somewhat. I know there's some similarities in the nodes, but if you're going from Blender, you're going to have to learn new names for some of the nodes. I'm sure there's similarities in math functions, like if I type in vector, we can see there's a bunch of different functions just related to vectors. Constants right here, which this will create a color, just like up here, but this isn't a parameter, so you can't edit it. But
thank you.
Yeah. Yeah, there's probably some similarities, but you'll need to learn new names. That's basically it, I think. So now we have our red material, and like you mentioned, we have this second copy of our existing actor. We just duplicated it here in the content browser, and now in MyCube 2, I can go ahead and where this material element is, I can just go ahead, and there's a few different ways to assign it, but what I'm going to do is just minimize down that a little bit and just drag it into element 0 right here, and it'll apply. So now we have this cube right here, which is red, and this cube, which is white. You can see this original one did not change because they're separate actors. And so now I can drag MyCube 2 into the scene, and it is red. And I can duplicate this one all I want. I can drag new ones in, just like I did that first time. And if I change MyCube 2, it will change all of those instances of MyCube 2, but not affect the MyCube 1, because they're different actors. So let's close out of these. I don't really need these anymore, because I just need one class. So I can go ahead and delete these now. There's a little bit of like a scary pop-up that can happen sometimes. If you're not using an actor for anything, you can force delete it, but always be careful deleting assets in Unreal, because there's a chance that you won't be able to recover it later. Because the way that Unreal stores these assets is it stores them as .u asset files. It doesn't just store them as files that you can open in other editors, so it's not just going to drop it in your recycle bin or something. If you force delete something, it's gone. So just always be careful about what you're deleting, but in this case, we don't need those, so I'm okay to delete them. So next up, what we're going to go ahead and do is create that barrel actor that we were talking about. And we could use the default mycube, or not the default, but the cube blueprint class that we just created. But I'm actually going to do something different just to show you an extra feature of the outliner. I'm going to create a new blueprint class. Just right-click in the content browser, new blueprint class. It'll be another actor, and we're going to name it barrel. And right now we don't have any mesh to put it in, so we're going to go back to our launcher right here. I mentioned earlier you can go from our library to the marketplace right here. And we're going to go ahead and search for a barrel. Once it loads, there we go. Now, I know that there is a, because I've seen it before, there is a pack on here called Industry Props Pack, but I'm just going to type barrel, because it'll search the description of these items too, and they usually mention what they contain. So, oh yeah, and one other thing, some of these cost money, but if you go over to max price here and click free, it'll just filter by free assets, and we see that Industry Props Pack 6. This is what I'm going to use. And this is a good thing to keep in mind too. Depending on your internet speed, this might take a moment. I know the pack is about, I think, 200 megabytes. So I'll go ahead and give people a second to download this, but basically it'll have a button here like that says free or add or something like that. And so go ahead and click that. It might show you a few menus, but it's a free item, so you should be able to just add it to your account, and then go ahead and click Add to Project here. Go ahead and add this to our project, and for me it's my first project. Choose whatever you made, and then click Add to Project. And what this is going to do is download the asset. It's already downloaded for me, so it was just pretty much instant, but for you it's going to take a minute probably.
I had a question.
Yeah, sure.
So, I remember like that you need to have the exact version of Unreal to use the asset pack. How would you save space? Because I'm running kind of low on disk space.
Yeah, that's a challenge with working with Unreal projects, because the file size of everything is pretty large. You're working with pretty high quality assets, and the engine is massive. Are you saying are you asking about specifically the version, the version of the asset itself, or of the editor?
It's like I remember wanting to use a certain asset, and it required me to use a different a different version of Unreal. And I had, by the end, I had 4 versions of Unreal, and I was like, oh my god.
Yeah, so some assets you'll find on the marketplace only support up to a specific Unreal Engine version, and you will have to install a new copy of it for each engine version. That's just kind of a quirk of the platform, I guess.
And you have to use that to convert it to the newer version? Yeah,
so it's difficult. Really, the only suggestion I can offer there is to try and make sure that the version of Unreal you're working with is you're only working in 1 or 2 versions, because if you're switching between projects of different engine versions, you're going to have to install assets for all of those versions, and if you have to convert your project to a new version, that can sometimes be a little headache-inducing. Sometimes things don't compile right, and it gives you really cryptic errors. So just try and stick with 1 or 2 versions, and make sure that your project isn't going to change versions. And if it is, just expect to probably deal with some headaches in converting it.
And just to add, under the hood, these are still just 3D models and materials. So you could hypothetically just drag the 3D model files and the PNGs for the materials into a different project, and most likely it'd work fine. But it is better to do it the proper way because you might be missing out on certain features like lighting that's pre-included and all that sort of stuff.
Yeah, that's totally something you can do, and it should work in most cases where it's just assets like this. Just keep in mind that these aren't stored as FBX, OBJ, PNG files. They're stored as .u asset files. So if there's a change in the way that these files are saved over a certain engine version, that's going to cause some issues. So feel free to try it. Just be aware that it might not work the way you expect, and you might still need to download the newer version anyways. So yeah, it's always good to you can try it though.
Thank you very much.
Mm-hmm. Okay, so hopefully most people have this downloaded now. Is there anyone that's still downloading the content here? Okay, awesome. So if you've gone and added that to your project through My First Project, or whatever you have saved, it should now appear in the content folder right here. You see Industry Props Pack 6. That's the one that I chose. And we can go into our meshes here, and there's a bunch of assets that we can work with. For now, I just want to work with the barrel asset. So I'm going to go ahead and open up the barrel actor that I made just in the base content folder. And sometimes it pops up with just properties, but if you want to go into the full editor, there's a link right here.
Oh, I've never seen that. That's interesting.
Yeah. No, but this might pop up when the actor is empty. I'm not actually sure, but you can always just get around it by clicking Open Full Blueprint Editor, and it'll bring you right back to the menu that you're used to. So, and we can go over to our viewport right here for 3D view, and then I'm going to go ahead and just go back to where I had those assets in here, and just drag SM Barrel 01 into my actor right here, into my blueprint. So you'll see that added it to the scene. It might not be centered because it was gonna, or no, it was. Okay. So it just dropped it right in the center of my actor right here. And if we save it, Control S, and minimize this, we can go in here and drag our barrel class out into the level. And you can see it plopped it down. It plopped it right on the surface of the level because our barrel, as you can see, it's not at the center of the actor. It has that offset, and that's just a part of the mesh. But that makes it convenient for us because we can just kind of drag more barrels in, and it'll put itself on the ground like you'd expect. And so if we go in-game, we can see those barrels are probably a little small. They're okay. They're fine, I think. But I'm going to scale it up just to show you. You can see right now, if I just do 1.5 on the x-axis right here, it's just going to stretch it and make it look all weird. But if I wanted to do it uniform, I can click this lock icon right here, and that'll make the scaling uniform. So if I want to make this 1.5, it'll scale it up on all axes. So now that's just 1.5 times the size. They're a little bit bigger. And if I go ahead and play again, you'll see it's much closer to the size of my character. This is not a realistic barrel size, but I just wanted to show you that uniform scaling thing. So we can keep using this now, and next up, I think, the other thing is right now they're just static. If I play again and just run into them, they're not going to move at all. But I want these to simulate physics. So if you go into the details pane right here in your actor, you'll see physics, the little physics tab right here, and simulate physics. So if I click the check mark on there and then save and go back, when I run into these barrels, they're going to act like actual physics objects. And I can push them around, Oh, look. Wow. That was interesting.
I usually add some, there's a slider called damping, linear damping.
Yeah.
And that will kind of adjust how easily your object resists movement, kind of like inertia.
Mm-hmm. Yep, you've got a bunch of properties here that you can adjust for physics, and you can go really in depth with this. There's there's physics materials that you can apply, but that's kind of outside the scope. But you can make some really intricate physics interactions with that.
I had a quick question. How do you determine if a physics object is sleeping?
If it's sleeping, so there's...
How would you determine if it can sleep?
Oh, if it can sleep. There's properties that you can change for that. I know there's start awake, which if you uncheck this, it'll initially be sleeping. And there's properties like you can see the sleep threshold right here. This just changes how likely the object is to like go to sleep if it stops moving. I'm not familiar with a toggle to completely disable sleeping, but I'm sure it's an option here in Unreal. Is that kind of what you were asking? Like how to adjust its tendency to sleep?
Yes.
Okay, yeah. So there's those properties. And like I'm certain there's an option to completely disable sleeping if that's what you want, but I'm not familiar where it is. But
and I will link at the end of this event to Unreal Engine's learning content. Some of their documentation's not so great, but they do have like video tutorial series. Like I just followed one of their video tutorials for creating an aim trainer, kind of like Aim Labs, except much more basic because I'm learning. And so some of those tutorials are great next steps if you want to learn more about Unreal after this event.
Mm-hmm. Okay, so we have our barrel. It's simulating physics, but now we want to make it explode. So what I'm going to do now is introduce you to the event graph. So this is where all of our blueprint code will go. And you can see by default, there's 3 of these nodes. These are just the default functionality that comes with all base actor classes. Begin play is the code that runs, when you begin the scene. Begin overlap, this is just has to do with collisions. And this isn't really relevant to us because we're going to create a new event, which I'll show you in a second. So I'm going to delete that, actually, the delete key. And tick runs every game tick. So you can think of this as, running every frame, although the tick speed of the game might not fully match up with the frame rate. But you can measure the length of it too here, which allows you to do some really useful things if you want to make something, for example, move at a constant rate. You can apply that delta right there, which is the time it took to execute a tick. And you can apply that using some math to your movement to make it move constantly.
And just to make it very simple, like an example of where you might use that, let's say you have a platformer and you have a platform moving back and forth. Mm-hmm. You might have it update its position every tick. So then you would use event tick.
Yeah. Yeah, and there's a bunch of ways to move stuff around too. Like you can create animations and you can just interpolate things. So there's a bunch of different ways to do it. But we're not going to go into any of that right now, so I can throw away the tick as well. And in fact, I don't even need begin play. So if I go into the viewport here and click my barrel, I can scroll all the way down the details pane, and you'll see these are all of the events that I can attach that are associated with this mesh. One of them is on component hit, and that's what we want to use. So this event is going to fire whenever anything hits the mesh. So I can just click the plus button here, and it adds it to our event graph. Okay, and so just to introduce you to these things, this is the execute part. I guess I'm actually not familiar with what they're called, but
yeah, it's called execute.
Yeah, like for all these.
Oh, like
the nodes.
Yeah,
yeah. But if you attach something to this, this is going to execute immediately when the component is hit. So let's say we just want to, for now, do a print, and we can print a string. So you can see when I just dragged it out, it just popped up with this, and I just typed in print in the search bar, and this is the first node that popped up. There's a bunch, but let's say I just want to print a string when the barrel is hit. I can say like barrel was hit, and switch over to here. When I start it and run into this barrel, you can see it says at the top left, barrel was hit. And it's going to say it a bunch because this event keeps getting fired as like I collide with it and as it collides with the ground, but that's essentially what that does. So now we have an event set up that'll fire whenever that barrel's hit. But we don't want this thing to explode just like when anything hits it, like if I just run into it. We only want this to explode when the projectile hits it. So one useful piece of information we need here is what the actual projectile actor is. And I'm assuming it's in first person or FP weapon, but I can just search it here. Projectile. And there we go. Yeah, BP first person projectile. This is what gets like, here, I can show you too. When I grab that gun, it instantiates, or it creates a copy of that first person projectile, and that's what you see flying around there.
Sorry about the noise again.
Yeah, it's ridiculously loud. Okay, so we know what the class is for that projectile, and we have a few useful properties here. One of them is other actor. This is the other. Well, it's pretty straightforward. It's the other actor that hit it. So I can branch out from this, and I can type in get class, and you see at the bottom here. What this does is it gets the class that is associated with. And we can branch out from this as well and do class is child of. It's going to like take time to, if you're really looking to get into Unreal Engine, to like memorize these nodes and figure out fully what they do. But there's some documentation and learning resources that are really helpful in really figuring this out. So for now, I'm just kind of running through pretty quickly kind of what I would do to make this barrel explode.
I just like, okay, is there a get velocity function? So like if something really fast hits it, it could explode?
There's not one that breaks out from the component hit, but you can go ahead and get the other actor, and then there's probably a velocity. Yeah, get velocity right there. And then that gives you the vector of that other component's velocity, or that other actor's velocity. So let's say that the projectile hit it. This value right here is going to be the velocity of that projectile at impact. So if you want to, you could always, check that value, and if it's above a certain threshold, then explode the barrel. That's totally a reasonable way of going about it. I'm showing you the class version just because it gets more introduction to, how these blueprint actors and classes work. But there's a bunch of ways that you could do it, and velocity is definitely one of them.
Good question.
Mm-hmm. Yeah.
And I'm sorry, another question. How is Unreal Engine's physics calculated? Deterministic or the other one? I forgot because it would travel through an object if it's going really fast.
Yeah, I think you can actually switch between different modes. I believe there's I know what you're talking about, and I remember the other mode for physics, but I remember there being options for setting how many iterations you want for your physics. And there's ways of switching specific objects over to deterministic, but I don't remember where that is. But I know there's a ton of options for Unreal's physics in general, and I do believe there's ways of switching between them. I'm not sure what the default behavior is, but there are ways of switching between deterministic and like iterated physics.
Thank you.
Mm-hmm. Okay, so we've gotten our class of the item that hit the barrel, and now we just want to make sure that it's a projectile. So we can see the parent class here. I'm going to go ahead and select class, and we can type in here projectile, and we'll see that BP first person projectile that we saw down here pops up, and can go ahead and click it. And another shortcut that we can pull up here, like I showed you earlier with the material of holding down the V key and clicking on the graph, right here we can hold down the B key and click on the graph, and it creates a branch. This is basically just an if statement, and we can connect this straight up to our event, and this is going to execute the if statement. And this class's child of provides us with a Boolean right here. And if we hook that up to the branch, that's basically just going to test if the object that hit the barrel is a first-person projectile or not. And if it is the projectile, we can go ahead and actually, blow the thing up. Otherwise, we can just leave this unattached because we don't care about it if it's not a projectile. So if it is, the first thing that we want to do here is, I guess I'll show spawning emitters and all that.
I think we can do it.
Yeah. So,
I was wondering, do we need to hook the event because the whole information getting does not run when the hit happens?
So yeah, when I went over to the barrel right here and went down to this events tab, when you click the plus button, it automatically creates that event and it attaches it to that mesh right
Yeah,
here.
but like they get class and they get child up. Those don't run when it gets hit. It only happens when the branches runs, and then it kind of gives us all that.
Yeah, that's a kind of confusing part of blueprints at first, but these will all run as long as they're attached to a branch that requires them. So in this instance, you can see that the Boolean is attached to this class's child of node right here. That means that this is going to run, but because this test class right here is attached to this node, this is also going to run. So as long as these nodes are attached to this branch, they'll run. It's kind of confusing because you don't actually get a little execute node right here to attach to them, but these will run just because they're attached to something that does execute.
Yeah, the only thing that's actually going to run is something that has a white pin. It's called an execute pin connected to it. So in this case, on event hit, it runs the branch. But then it kind of goes backwards to see what's inside the branch, to look at the condition of the class's child of get class. That all kind of runs once it hits the branch.
Yeah, and it checks all of this when it's compiled. So it'll... it's not like when it's actually running the game, it's going to check this branch, look back, and do all of that. Like it'll compile all of that into a more efficient process. But that's what it does, when it first looks through the blueprint. And if I detach this, break this link.
Good keyboard shortcut. If you want to disconnect something, hold down the Alt key and click on it, and that will cut the connection.
Mm-hmm. If I disconnect that branch, this is not running anymore. So these are also not going to be relevant and aren't going to run. Even though it's connected to this, these aren't associated with a node, on the return side, on the output side, which is going to be always the right side of a node. Because these aren't connected to something that executes now, this all isn't going to run. But if I attach this to the onComponent hit, now it will.
Understood. Thank you very much.
Mm-hmm. Okay, and now we're going to go ahead and spawn an explosion effect. And so the first thing I want to look for is a particle effect. And I believe that's in the starter content here. These are the assets that are applied to your game if you click that starter content checkbox when you're initially creating the project. And these are pretty useful to prototype with or just use if you want. But I want to go into the particles folder, and you'll see there's an explosion particle right here.
Drag it into the level.
Mm-hmm. Yeah. I can drag it in there and boom. You can see it's not going to repeat. Oh god. It's not going to repeat. You can make it do that with properties, but by default it just blows up once because that's all you need from that particle effect. I can also drag fire in right here, and you'll see some pretty nice effects. But for this, we need the explosion. So I'm going to go back to the event graph right here. And from this true node, so if the class of the object that hit the barrel is a projectile, I'm going to go ahead and do spawn emitter at location. And what this will do is it'll let me select a particle emitter to spawn, at this location vector right here. We don't really need to worry about rotation or scale. For now, we just need location. And we will get that from the location of the barrel and do some weird stuff to offset it to be... or I guess we don't need to offset it here because it's just an explosion effect. If we were doing something like fire and we wanted to set, the top of the barrel on fire, we need to get the position of the barrel and then look at the top of the barrel by adding half of the size of the barrel to its position, and then we can put the particle effect for fire up there. But because we're doing an explosion, I'm just going to put it at the center of the barrel. So all we need to do for that is our hit component here. Because it's attached to the barrel static mesh, it's always going to refer to this. Well, we can actually just click on this and drag it into, and that creates a reference to it. And in this case, it's actually going to be a little bit cleaner to do that, because I could drag this hit component and bring it all the way over here. Oh, that's not the right one. But I could just drag this out and do get position, or world location. And feed it over here, but you can see it's overlapping with a bunch of other stuff. So it's totally possible too to just drag this out right here and just use it where it's needed. And so I can I can drag out from there and do get world location. And this is going to get the position of the barrel in the world, and I can just attach that to the location right here. And so we do want it to auto-destroy because we don't need it after it's created. And let's go ahead and select the explosion, which comes up right here as the emitter template. You can choose which particle you want to use there. We're going to use the explosion. And as we create that explosion, we don't really need the barrel to exist there anymore. So we can just branch out from that and destroy actor. And this isn't going to delete the explosion because we just chose the spawn emitter at location node. If we branched this out and did spawn emitter attached, you can see that might parent it to this actor. And then when you called destroy actor, it would delete the particle too. But because we're just doing spawn emitter at location, it just drops it right in the world. And that auto destroy lets us not have to worry about it at all once it's created. And then we can just go ahead and destroy the actor. That destroys the whole barrel, everything here. And
yeah, and if we didn't add that destroy actor node and we were to run it, it would show the barrel explode, but then the barrel would still just be sitting there. So you want to get rid of it.
Mm-hmm. Yeah, and of course you can also add some like special, more interesting effects to it, like replacing it with an exploded barrel static mesh, or breaking it apart into like gibs. But for now, I think it's reasonable enough just to destroy the whole actor. So then we've saved that. I did Control S to save the code.
Got to compile it too, right?
It should be good for now.
Okay.
Yeah, I think. If we're compiling it, we can. We do that before we build it.
Well, usually I always click compile save every time just because that's what all the tutorials I followed taught me to do.
Fair enough.
But
yeah, I'm usually okay just to Control S on it.
Okay.
We'll see though. If I go into here, pick up the gun, and shoot. Boom.
There you go.
Yep. Oh, right. So that's so you noticed when I hit this, the explosion particle spawns at the bottom of the barrel. If I want it to apply to the center, and well, the reason that it does that is because in our, like I mentioned earlier, in our actual static mesh here, it's placed at the bottom. The center of this mesh is at the bottom of it, just to make it easier for level design and such. But in our case, we want to put it, at the center here. So what I can do instead here, and this is going to be a slightly weird way of doing it, but I kind of want to show vectors and math in a little bit. So we have our world location right here. And what I want to do here is get the sort of the volume of space that barrel occupies. In this case, I only care about the z-axis, which is that blue up and down. And I want to get half of that space, half of the size of this barrel, and then add it to the world location. So it goes to the center of that barrel, wherever it is in the world. So what I can do here is I can use the barrel again, and I can get the component bounds. Get component bounds. And you'll see we have collision, get component bounds right there. You want to use this. You don't just want to grab the component and then do get scale, mass scale or world scale, because that's always just going to return a scale of 1, or like whatever, 1.5 in this instance. Because it's the world scale, it'll get this scale multiplied by, whatever you set it in the world. Like I showed you earlier, it multiplied 2 by 2 to 4. But we don't want that. We want the actual, volume of space that barrel occupies. So we're going to get the component bounds, and that just gets us the physics, bounds that it occupies. And we don't even need get world location anymore because this node right here gives us an origin. So let's go ahead and break this off. We can break off the box extent right here, and I can do that by typing break vector, and I'm just going to use the normal break vector. And this just breaks the vector up into its XYZ components. And in this case, we only need the Z component, that up-down axis. So now I can right-click and make vector and just hook the Z-axis into it. And so we have the Z-axis of the component bounds, and we can drag this over and do add, and this gives us a function to add two vectors together. And I'm not great at organizing nodes, but let's attach those together. So now we add the origin of the barrel to the z-axis of the amount of space that the barrel occupies. And so now I can just hook that straight into the location for the emitter. And when I hit play here, go down, shoot, now
There
you
we
can see it
go.
does that. It happened on top, so if you want, you can go in here, divide by 2, and that'll put it at the actual center of the barrel. And I can demonstrate that real quick. I'm going a little bit fast because we're running out of time, but now if I shoot it, you can see it's
pretty good,
yeah.
One other thing I want to add, when you can see that got messy pretty fast. I mean, we didn't actually write that much code, but there's so many lines going everywhere. So if you are going to commit to programming this way and not typing code, you're going to want to do a lot of commenting. And so the way that you comment in the blueprints, you literally just drag a box over everything, and you can right-click. Oh, did they change this in 5? Where's the comment feature? Create comment from selection. They moved it to the bottom. Okay, used to be at the top. You can create a comment from a selection, and that will put a big box around all of your code, and we can call this explosion code, right? And you can set the color of that comment, make it red and stand out. And so then if you had some other code down here, you could create a different comment with a different color. And this is sort of a good way of keeping everything nice and tidy.
Yeah, so we're running low on time here. I do want to show one more thing really quickly, though, and that's just creating like a sound, an explosion sound at that point. So what I'll do next here is play sound, and you'll see there's a play sound at location node. And for this, we could plug in the same position that we created for our particle effect, or we could just plug in the position of the barrel. It's a sound, so it doesn't need to be as accurate, but I am going to go ahead and use the same one as our original, as our projectile, or our particle effect, sorry. And if I go ahead and double click this line here, you'll see it creates this little extra node that you can move around, and you can like reorganize your lines a little bit just to make it more clear so it's not overlapping with other stuff. So our position that we used for our emitter is also now being used for this play sound node. And I'm just going to type in explosion. I'm sure there's explosion sounds. Yep. You'll see there's sound wave and then sound cue. This cue has programmable properties to it. So like in this instance, this cue is set up so it'll randomly select between one of these two waves, or one of these two sound files, and it'll like adjust its pitch and volume a tiny bit just to make it sound a little bit more natural. So I'm going to go ahead and select that one because that'll be a little bit nicer. And we can go ahead and scale this comment down a little bit.
Sound warning. There's probably going to be some strong echo on this.
Oh, yeah. Mm-hmm.
Maybe I'll just mute for this.
Yeah.
So, there you go.
Yeah.
That about wraps up all of the topics that we wanted to cover for the beginner event, I believe, yeah?
Yeah.
So, unless you have any particular questions, then we are all done here.
I had a couple of questions, so I was taping up. So, I've tried before, and I was wondering, why would one use the blueprints over C++ for and like what's the performance-ish difference between like C++ and blueprints? And the second question is, how would you make custom movement in the game? So
the difference between them in performance-wise, blueprints are definitely slower than just writing native C++ code. The benefit here is just, for one, it's easier. It has a lower barrier to entry, so it's a lot easier to, visualize the code this way than it is to write in C++, especially if you, don't know how to write C++.
Well, and it's worth adding, Unreal Engine C++ is almost like its own language because there's so many specific functions to memorize that they're specific to Unreal Engine. Yeah. So even if you do know C++, there's still a pretty big barrier to then writing Unreal Engine C++ code.
You have to learn what all the functions are, what all like the macros are. So like the uClass macro,
like the API.
Yeah. There's still a lot that you need to learn about like how Unreal Engine C++ in specific works. Because there's a lot of
complexity.
Complexity to it. So one of the benefits to Blueprint code is that you can just start doing it immediately, and to some people it can be kind of natural. But I can also understand that for some people this can just like very quickly turn into spaghetti, and it's much easier to write C++ code. So it really depends on your personal preferences on that. Performance-wise, like you mentioned, Blueprint code is slower. In older versions, in Unreal Engine 4, you could do a thing called Blueprint nativization. And that was a property in your file up here, edit project settings. I'm not going to go into that right now, but it basically, when you compile everything, it converts it into native C++ code, but it's still a little bit messier, and it's not going to be as fast as just writing, bare C++ code.
Yeah, and there are limitations as well. For example, if you're using blueprints, it's very hard to do anything multiplayer. I mean, it is possible, but not everything is possible. I looked into making like a little demo first-person multiplayer shooter game, and it wasn't... It was going to be very complicated to try to do via blueprints versus the features that are built into the C++ version.
Yeah, there's a lot of functions that are built into the C++ that aren't exposed as blueprint nodes that you just can't access without writing C++ code. So if you're going for some really complex behavior, you might need to go to C++. So it's a case-by-case basis kind of thing.
Sorry.
Okay. Sorry for cutting you off, but so how would you make movement, and also how do VR work in Unreal?
There's plugins for Unreal Engine that work with like OpenXR, so you can create VR stuff. I actually haven't worked with VR in Unreal Engine, so you'd have to look up one of the like Unreal like learning things for it. There's a bunch of online resources for that, besides just like YouTube videos. Like there's a really good resource for Unreal Engine tutorials that are made by the engine developers.
I just wanted to add that when you are done with your project and you want to turn it into an actual runnable exe, Unreal Engine, one of its main advantages is it can export to pretty much any platform. So you could take this little barrel game we made, and you could export it to an iPhone app, to an Android app, to a Mac application, to a Windows exe, and it wouldn't take that much work on your end other than maybe editing a couple of like registry things, like keyboard controls or whatever, So that's worth noting. And VR is also a built-in thing. I believe there's a template for it. You know how we started on the first-person template? I think there's a VR template, and so that will just work with your VR headset by default, I believe. As far as adding movement, you asked, I would say you're saying you want to not use the first person and create your own controller instead?
I don't necessarily mean getting rid of the first person controller, but like I remember because I've used a different game engine. I used the Roblox game engine for a while, simply because of the multiplayer aspect. And I remember if I wanted to create, for example, a custom movement control, I had to add like this really odd thing that I kind of came up with myself, was just adding a capsule around the player. And do you have to kind of do the same thing in Unreal, or can you like add features on top of the first person control? Does like have an API for that?
Oh, you can attach stuff to the first person controller for sure. You can actually open up the blueprint code for the first person controller, and then you can just start adding blueprint nodes from there as if you were doing any other blueprint. Here, it looks like he's opening up. Yeah, so here you go. You can see all the camera input, all of the movement input. It has all the blueprinted code for you, and you can add on to that.
Yeah, one other kind of important thing to note too is one of the changes made in Unreal Engine 5.1 is that they changed the input system. So if you're at all familiar with older versions of Unreal where you'd go into your project settings and look for the input in here, if I go in here and show it right now, you see it says that they're now deprecated. So they now want you to use enhanced input actions, and these are a lot more powerful, but they're also more complicated to set up because you have to actually create objects in your content browser that represent all of your inputs and everything. So it's a whole thing to set up. But if you're, for instance, trying to create custom movement and you need to accept users, like the user's input for pressing like the tab key or the E key or something or whatever, you'll need to use that. And if you've used this system before, you might not want to use 5.1. I kind of personally wish that they left this here and just created enhanced input actions as like a plugin that you could install, but it is what it is. So input is a little bit complicated, but it is doable. And if you look up online, there's a bunch of resources for learning how this new system works and how the old system works.
One other really quick thing worth mentioning, the level blueprint. So this is the blueprint for the level itself. So you can have, multiple levels that you could switch between. But yeah, if you go to open level blueprint, like Lucian just showed, you could put code that kind of manages the objects that are in the level. So say you have something that's not an existing blueprint, that's just like a cube you had in the level, you could make it have some functionality here from the level blueprint. You definitely don't want to overuse this. Like when I started learning Unreal Engine, I was doing my entire project just in the level blueprint. That's bad. It's much better to, as Bill would say, encapsulate everything within classes. But it is possible to just put everything. You can kind of think of the level blueprint as a main, but not really. So
yeah, I'm just doing something real quick to show you. I added this code that on begin play, so when the level starts, this is running in the level blueprint, and it'll just get all of those my cubes that we created right here and just destroy them. So when I play now, you'll see those cubes have vanished because when the level started, it went through all of them and deleted them. So that's just a really, really quick example of
get all actors of class for each loop, destroy.
Yeah, so you'll see some familiarities here, like this for each loop just takes this little box icon here means that this is an array. And in this instance, if you hover over it, you see it's an array of my cube object references. So that's really useful. And then you can just drag out of it for each and, loop through it.
All right, we are 10 minutes over time, so we may want to cut it off here. Is there any other really quick question you want to throw in?
Yeah, just a quick question. Where would I find the API for all the class types?
I will send a link in the voice channel chat, and I will @ you to all of the Unreal Engine learning docs.
Thank you.
I'll do that after the event ends. All right. Well, thank you all so much for joining us. I think that was a good little test run of like an Unreal Engine event. Maybe we'll do more if people request it. So thanks for coming.
Yeah, for sure. Thank you.
All right. Bye, everyone.
See ya.
Thank you.
Thank you.